Hi, welcome to Send to Print. Someone asked in the comments how to model a chess box. In a previous video, we built this hinged box. It works really well as a regular storage box, but it doesn't work as a chess box as is because it can't lie flat on the table. The reason is that the hinge axis sits outside the box. When it opens, it leaves a big gap in the middle, but for a chess box, we want to keep that gap as small as possible. This raised hinge also keeps it from lying flat on the table. So in this video, we'll rebuild the hinged box specifically as a chess box. All right, let's dive right in. Before we begin, let's take a quick look at the chess box design, especially the hinge. The hinge axis runs right along the seam between the two halves. This lets the box close properly, and when it opens, the two sides meet almost seamlessly. That's the key requirement for a chess box. Let's start by defining some key parameters. Go to the Modify panel and select Change Parameters. First, the box width is 30 millimeters. This is the width of each half. Then the box length is 60 millimeters. For the box height, this also refers to one half. I'll set it to 10 millimeters. Finally, the wall thickness is 1.5 millimeters. To keep the test print quick, I kept everything fairly small. If we want to change the dimensions later, we can just reopen the parameter table and edit the values here. Right-click the root component in the browser and create a new component. We'll start with the left half. Create a sketch on the XY plane. Draw a rectangle using the length and width parameters. Constrain its center point to the origin. And that's our base profile. Finish the sketch and rename it to bottom. Press E and set the extrusion distance to height. To hollow it out, find shell in the toolbar, pick the top face, and enter the thickness parameter. Now let's look at the design. The hinge sits in the middle, and if we want to print it without supports, this inner wall needs to be a little thicker so the hinge can print directly on top of it. Back to the model, press Q for offset face. Select the inner face and offset it inward by 1.5 millimeters. That finishes the main body of the left half. Since the right side is identical, we'll just use the mirror tool. Change object type to component because we'll assemble these later, and joints only work with components. Select the left component and mirror it across the YZ plane. Right-click the new component and rename it. Now we have both halves of the box. I'm pressing Shift+N to turn on component color cycling. This doesn't change the material or the final print. It simply gives each component a different display color, making their relationship much easier to see. The main body of the chess box is now finished. For now, the two halves are only touching. They aren't actually connected yet, so we'll model the hinge next. Let's take a quick look at the hinge design for this chess box first. The hinge is fully symmetrical. I left a 5 millimeter gap at each end, so the pin is hidden when the box is closed, and all 5 hinge knuckles have the same length. Back to modeling. Let's start by sketching the hinge on the XZ plane. Press P and project the edge of the left box into the sketch. Hide the body for a moment, and draw a 2 millimeter circle. This is the hinge pin profile. Then offset it outward by 1 millimeter. This outer circle defines the hinge knuckle. Next, draw a line from the box edge to the outer circle. This keeps the print from starting at the very bottom of the circle. Add a tangent constraint here, and press D to set this angle to 30 degrees. Now mirror this line to the other side, because we'll reuse this sketch for the other half later. Before finishing, check for that small lock icon. It means it's fully constrained. Okay, let's finish the sketch and rename it to hinge. Next, we'll build the hinge knuckles on the left half first. Press E and select these profiles. Start the extrusion from this outer face. Set the offset to -5 millimeters. For the extrusion distance, use length -5 millimeters from each end, then divide by 5 since we have 5 hinge knuckles with the same length. Set the operation to join and hit OK. Next, we need a helper plane. Find offset plane. Offset this side face toward the center by -5 plus length -10 divided by 5 times 1.5. That puts the plane right in the middle between two hinge knuckles. Now we can use this middle plane for the mirror. Set object type to feature. Find that extrusion feature in the timeline at the bottom. For the mirror plane, select the construction plane we just created. Now we have the center hinge knuckle. Hide the construction plane for now. Go back to Mirror under the Create menu. Select the extrusion feature and mirror it across the XZ plane. And just like that, the 3 knuckles on the left side are done. Next, we'll build the matching ones on the right half. Right now, the left side knuckles overlap with the right component, so let's cut away the overlapping part first. We'll set the right half as the target body and the left as the tool body. Set operation to cut and turn on keep tools. Otherwise, the left half would be removed. Now the overlap has been removed. Turn the hinge sketch back on. Press E and select these profiles. Choose this face as the start face. The extrusion distance is the same, length minus 10 divided by 5. And join them. Next, find Mirror under the Create menu. Mirror the extrusion feature across the XZ plane. Now, the 2 hinge knuckles on the right side are done, but they overlap with the left body. So let's go back to the left component. Cut the right component out of the left one. Keep tools on and confirm. Now the left and right parts no longer have any overlapping geometry. To get a better look at the model, let's go to the Inspect menu and select Section Analysis. Pick the XZ plane as our reference. If you don't see anything, just click Flip. Move the section view around and check the relationship. The 2 sides no longer overlap, but this is still not a complete hinge mechanism. The hinge knuckles are only sitting next to each other. They still don't have an actual hinge pin. Open the hinge sketch again. Press E and select the center circle. That is the hinge pin profile. Change the start face to the side face of the first hinge knuckle and extrude toward the center. You could pull it all the way through and set it to join. That would create a continuous hinge pin, which requires bridging during printing. If the bridge sags, it may fuse to the other hinge knuckle and make the hinge hard to move. So we'll use a different approach here. Set the extrusion length to 5 for now, but change the taper angle to -45 degrees. Now it becomes a 45-degree tapered protrusion that acts like a short hinge pin. It can print directly, without bridging or sagging issues. Now use Mirror again to create the matching one on the other hinge knuckle. Now we have a symmetrical pair of hinge pins. Right-click and repeat the Mirror command. Select those 2 features and mirror them across the XZ plane again. Now the other side is done as well. Next, we need to create the matching holes for these short pins on the other half of the box. Go back to the right component, find Combine under the Modify menu, cut the left part out of the right part, keep tools on, and confirm. To check the internal fit more clearly, create another section analysis. This time, select the top face of the box. Now you can see that the hinge pins and matching holes fit properly. All right, let's put everything together. Under Assemble, choose As Built Joint. Select the left and right components, then set Motion Type to Revolute. For the snap point, click this line between the 2 parts. We can also set the minimum and maximum angles to limit the opening range from 0 to 180 degrees. Drag the component to see how it rotates. At 180 degrees, the box closes perfectly. The hinge mechanism works, but it's not ready to print yet. When the chess box is opened flat on the table, the hinge sticks out below the box. It will make the box wobble, and nobody wants to play chess on that. The problem is, the hinge has to stay exactly where it is. This position is what lets the box line up when opened, while still allowing the box to close completely. The simplest solution is to add small support feet on the inside of each half. They're the same height as the hinge, so the box sits flat on the table. Let's return to the main view. Create a sketch on the inner side face of the box. Press P and project this edge into the sketch. Then hide the bodies for a moment. We need to draw a small support foot here with its top face level with the top of the hinge. Start by drawing the rough outline with the line tool. Press D and set this height to 2 millimeters, which matches the hinge radius. Set the width of the foot to 5 millimeters. Then set this angle to 45 degrees. Constrain these two lines to be equal. Now, everything looks fully defined. Okay, let's finish the sketch and rename it to feet. Next, turn the bodies back on. Press E and select these two profiles. Offset by 2 millimeters. Extrude toward the center by 5 millimeters. Make sure the operation type is set to join. Now we have a small foot. Its top face is level with the hinge, so it supports the box and keeps the board from wobbling. You can make this top face flush with the hinge or slightly higher. Just don't make the feet lower than the hinge. To create the matching foot, mirror the extrusion feature across the XZ plane. Next, use mirror again to copy these 2 feet over to the right component. Now we have 2 new problems. First, these 2 feet are still inside the left component. Second, the feet on both sides line up exactly. When the box closes, they will hit each other and stop the lid from closing. Let's fix the collision problem first. Press M for move. Select the first foot and move it inward by 6 millimeters. That's slightly more than the 5 millimeter width of the foot. Right-click and repeat. Move the other one inward by 6 millimeters as well. Next, go back to the right component. Combine the box body with the 2 feet. This time, you do not need to keep tools on. Now, when the 2 halves close, the feet on both sides are staggered, so they no longer block each other. With the box closed, there's no longer any interference. If we hadn't moved the feet, they would line up right here and prevent the 2 halves from closing. Now, we have a complete hinge mechanism, plus 4 matching support feet. Next, we'll add snap fit features to the box so it clicks shut without needing extra magnets. We'll model this while the box is in the closed position. So let me capture the position first. Create a new sketch on the XZ plane. Press P and project the inner side of the box. Hide the bodies for now. I'm using the line tool to sketch a rough outline first. Constrain these 2 edges to be perpendicular. Do the same here. And make these 2 edges parallel. Finally, press D to add dimensions, like setting this angle to 45 degrees. Keep adding dimensions to the remaining edges until the sketch is fully defined. Set the width of this snap bump to 0.8 millimeters. Check if it is fully defined here, the small lock icon. Finish the sketch and rename it to Snap Fit. Now let's add the Snap Fit catch to the left half first. Press E and select the profile of this catch. Turn the bodies back on, then extrude this bump symmetrically to both sides. Set the total length to 5 millimeters and join. Now the bump on the left half is finished. Let's make the matching snap hook on the other side. Toggle on the sketch again. Press E and select the hook profile. Extrude symmetrically to both sides with a total length of 5 millimeters. The snap fit mechanism is now finished. When the box closes, this cantilever hook flexes slightly, then snaps into place. That's where the click sound comes from. Now, the 3 main functional parts of the chest box are complete: the hinge, the 4 support feet, and the snap fit mechanism. But we still have some cleanup work to do before printing, because right now there's no clearance at all. For example, the 2 halves are pressed directly against each other, so the slicer would treat them as one solid part, and they'd print as one solid part. So let's add clearance to all the mating surfaces. Let's start with the hinge. Press Q to open the offset face tool. Select the mating faces on the left half. I'm leaving these faces as they are because I'll offset the matching faces on the right half instead. Now, let's work on the right half. Don't forget to select the pinholes as well. Offset all of these faces inward by 0.1 millimeters. There's now a gap between the two main bodies, so they'll print as separate parts. There's also clearance between the hinge and the opposite half, so they won't fuse together during printing. Finally, there's enough clearance between the pins and the matching holes for the hinge to rotate freely. With the hinges sorted, let's move on to the support feet. When the box closes, this face of the foot contacts the inner surface of the other half. So I'll add a small gap here so the parts don't rub against each other or block the box from closing. Right-click and repeat offset face. Select these faces and offset them inward by 0.1 millimeters. Finally, let's add clearance for the snap fit feature. Right-click again and repeat offset face. Select the two faces of the catch, and also the end face of the hook. Offset them inward by 0.1 millimeters. To make the snap fit engage more smoothly, add a 0.4 millimeter fillet to the edge of this bump. On the hook side, add a 0.2 millimeter fillet to the inner edge. Then add a 0.4 millimeter fillet to these outer edges. Okay, the mechanisms of this chest box should now work properly. To make the model look more refined, I'll add a small chamfer to the bottom. This also helps reduce elephant foot during printing. Just be careful not to chamfer these two center edges, or at least don't make the chamfer too large. When you're playing chess, you want the center seam to stay as flat and clean as possible. So, I'm adding a 0.4 millimeter chamfer only to the outer edges of the chess box. Now that our design is finished, it's time to get it out of Fusion and send it to the printer. Just right-click on your component or the root component and choose Save as Mesh. Everything looks ready. Send to print. After a 15-minute print, here it is. The first time you close it, press a little harder. Now it closes fully. Open it, take out the pieces, and flip it over to turn it into a chessboard. I know it's tiny, but it has all the features of a real chess box. Overall, I'm pretty happy with it. The hinge and the snap fit both work smoothly. Thanks to the support feet, it sits flat on the table and doesn't wobble. Looking back, there are two things I would change. First, the snap fit feels a little loose. It opens a bit too easily, so I think I'll make it tighter. Second, I'll soften the small, sharp edges where your fingers may touch. Back to Fusion. Find the snap fit sketch first. Increase the bump height from 0.8 to 1 millimeter. Then add a small chamfer to the top of the 4 support feet. Finally, add a 2 millimeter fillet to the sharp outside corners. This is the upgraded version. It doesn't look dramatically different at first glance, but it feels much better in the hand. The snap fit has a more balanced feel, and it's less likely to pop open accidentally if it gets bumped. Also, small details like fillets might seem insignificant, but they really improve how the model feels in your hand. Those tiny, easy-to-miss details are what make your design feel more premium. Okay, once you're satisfied with the model, you can go to the Modify menu and open Change Parameters. You can change the dimensions of the chess box by simply tweaking a few values. And that's the modeling process for the chess box. I've uploaded this model to MakerWorld, where you can customize the size of the chess box. And, as usual, channel members get early access to this video, plus a detailed cheat sheet and the Fusion file, so you can poke around and see how everything works. You may have noticed that the board surface is basically just a flat canvas. I skipped the board pattern to keep this video from getting too long. If there's enough interest, I'd be happy to make a short follow-up showing how I designed the board pattern and print it cleanly. Once you know how to make the board pattern, you're not limited to chess anymore. You can turn it into a Ludo or backgammon board, or anything else you can think of. For example, I also use the same hinged box to make a small tic-tac-toe box with a keychain loop. Open the box and pour out the pieces. You can pull it out of your pocket whenever you want and play a quick game with a friend. Okay, that's all for today. If you found this tutorial helpful, please hit the like button and subscribe for more 3D printing designs. Let me know in the comments what should I model next. Thanks for watching, and I'll see you in the next one.